we are going to discuss in this video the complex field. So let's remember what is a complex number. Here we are going to see complex numbers in a slightly different way from what we may be used to. Okay. Basically, they are always a pair, AB, okay, where A and B are real numbers, okay, and that's it. So here, it's very important when we give the pair of numbers AB, the order is very different. It's not the same if I write AB or if I write BA, okay? Unless A and B are equal, in that case, no problem. I mean in general. So there are two operations with complex numbers, right? The sum and the product. Okay, so the sum of two complex numbers. So let's say we have x that is AB and y that is CD, okay? So the sum x plus y is the sum component wise. So it's A plus C, B plus D. Okay, so this is the sum, the first one. And then the second one, the product. This we define as AC minus BD, AD plus BC. Okay, so this is how they are defined. Now, when we have the two operations defined like this, then the set of all complex numbers with these two operations, the sum and the product, is a field. Okay, and here we have the 0, 0 and 1, 0 in the role of 0 and 1 in the axioms A4 and M4. Okay, remember? All right, so this is it. This is saying that the complex numbers have the field structure, just like the real numbers. Okay, and I leave for you to check. I leave for you to check the axioms of a field. Okay, it's also in the book, so you can check your work there. But it's just checking that everything works as one would expect. All right. So one more thing that I wanted to mention is that the real numbers are a subfield of C. Okay. Here, what we need to realize is that we can identify the number A0 with the real number A. Okay, after all, if we add two of these numbers, A0 plus B0, okay, so what we are going to get is A plus B 0. Okay, and with the product, it's the same. If we follow the definition, A0 times B0 turns out to be AB0. Okay, and this is true for all AB in R. Okay, so basically even if the numbers look a little different because they have a second component that is 0, they are the same real numbers and they behave the same way we are used to. So then we can identify the subfield of numbers of the form A0 with the real numbers. Okay. Now you may be wondering what happens with the usual notation. Instead of usual, let me call it traditional. The traditional notation for a complex number is that the pair AB, we call it A plus BI, where I is the imaginary unit, okay? Within the notation we are using now is just 0, 1, okay? Now, usually we will write I equals square root of -1, okay? But this doesn't really, I mean, square root of a negative number is not defined. We just call it I, okay? But in truth, when we compute I squared, this turns out to be -1. But this needs a proof. Okay, so let's see if with these definitions we have, this is true. Okay, so proof, this is a simple one, it's just a comproval. So we multiply 0, 1 times 0, 1. Okay, and if we apply the formula, what we realize is that the product is -1, 0. Okay, remember, we have the formula here. Let's scroll up and copy it so that we can double check it. So we have the first 0 times the first times the first, 0 times 0, minus the second times the second, which is the -1, and then AD plus BC is 0, okay? So this is just a comproval. So this is minus, let's jump here, this is minus 1, 0, and we identified 1, 0 with the real number 1. So this is -1, and that's it. Okay, notice here we are doing two things. One thing is we have introduced the new notation I, okay, and we say, okay, this is 0, 1, it's a symbol for 0, 1, and we have also said that the real numbers, the symbol that the real number is represents the real number, comma, 0. Okay, so we are using those two facts. Okay, so with this in mind, actually we realize that for every real numbers a, b, the ordered pair that is a complex number a, b, actually it's the same as writing a plus bi. Okay, here we are saying that it's the same thing, and this is for all a, b in R. Okay, so this is again just a comproval using the new definitions, but let's do it. So a plus bi, so this is a0 plus 0b. Okay, 0b actually multiplied by I, right? What was I? So I was 0, 1. All right, so here we have a product. It's not like we have a lot of, here we just used the definition. Now we have a product, so let's do the multiplication. Let's see what we get. But when we do the multiplication here, we are going to get a0 plus 0b, and that gives the pair AB. Okay, so again, here we basically used the definition to reshape the expression we had. All right. There are a few more things that we know from about real numbers, like complex numbers, sorry, the real part, the imaginary part, conjugate, all those things that we will cover in the next video.